So in this note, I am going to be going through one more polynomial function, and then we're going to start to get into rational functions, which can be a little bit more complicated because of the many ways they can look. So when I ask you to analyze the key features, what we're going to be looking at are the intercepts, the x and y, critical points, intervals of increase and decrease, points of inflection, and concavity. So first we're going to be finding our intercepts. I'll start with the y-intercept because it's the easiest. We know that when we have a y-intercept, that means that our x value is 0. So if I go ahead and I plug in a 0 in for all of the x's in my original function, I am going to get y is equal to 2. So that means that we have the point 0, 2 on our graph. The next thing that I'm going to be doing is finding my x-intercepts. Now these ones are a lot more difficult to find. When we're solving for our x-intercepts, we can set our y equal to 0. Now in situations like this, we will have to factor, and since this is a power of 4, it's going to be a lot harder to factor than some of the easier formulas or equations that we're used to. And so I will have to be using long division. I do know that if I do f of 1, so if I plug in a 1 for all of my x's, that will be 0. So this is telling me that x minus 1 is a factor. So now that I know that, I can go ahead and do my long division and get that 1 degree less. So this is our long division setup. So my function divided by x minus 1, which I know is a factor. If you're going to pause the video right now and try and do this long division by yourself, that would be a good idea, but you should have had a lot of practice with this last quadmester or semester whenever you took functions. So in order to get negative 3x to the power of 4, I need to be multiplying my x minus 1 times negative 3x to the power of 3. So what I'm going to do every time is I'm going to remember to put a minus sign with a circle around it so I know it's not a negative, that it's a subtraction. And I have negative 3x to the 3 times the x, so that's going to give me a minus 3x to the 4, and then negative 3x to the 3 times the negative 1, so plus a 3x cubed. I get negative 3x to the 4 minus negative 3x to the 4, so that is 0, and then a negative 2x cubed minus 3x cubed, so a negative 5x cubed. At this point, I can bring down the rest of my terms, so plus 15x squared minus 12x plus 2. In order to get to negative 5x cubed, I'm going to need to multiply by a negative 5x squared. So I will get negative 5x cubed plus 5x squared. And that is going to leave me with nothing, and then 15x squared minus 5x squared, so a 10x squared. And then again, I will bring down the remaining terms. I did the next step for you, so I added a plus 10x in the top, multiplied through. I'm bringing down the last of my terms, which is just the 2, and then to finish this off, I'm going to have a minus 2, so minus 2x plus 2, and when I subtract that, I'm left with 0, which is exactly what I want to happen. So we know that we had one factor of x minus 1. This was the cubic that we were left with after we did long division. I'm going to go ahead and I'm going to try and find another factor. So if I try f of 1 of this cubic function right here, I will get negative 3 minus 5, which is negative 8, plus 10, which is 2, minus 2, which is 0, which is exactly what I want. So I know that x minus 1 is another factor. So since I just went through this, and since you would have had a lot of practice on long division already, I am going to go ahead and just show you the answer. So here's the answer with all of the work shown. I guess I didn't show what I was doing here, bringing that negative 2 down, but you get the point. So basically what we're left with is 0 equals the original x minus 1, this new x minus 1 that we just got, and the negative 3x squared minus 8x plus 2 factor that we just found by long division. Now at this point, since we have a quadratic, you can go ahead and see if you can factor that. In this one, we're going to be finding something that multiplies to -6 and adds to -8. I know that's not going to be possible, so what we need to do is jump right to our quadratic formula. So I filled in this information from the quadratic formula. Remember our A, our B, and our C. And since we're going to be graphing this, I am going to just convert to decimals right away. And so I have 8 plus the square root of 88 divided by -6, and 8 minus the square root of 88 divided by -6, and that is going to give me two answers. One is -2.9 and the other is 0.23. So I'm just going to go ahead and write what these mean. So I have one x-intercept at -2.9, another one at 0.23, and then again I have one at 10, and I see that twice, so I'm just going to leave myself a note that that's a double root, because we know visually that's going to look different than just a single root or a regular root. Next, we're going to be looking at the critical points. So we're going to be taking the derivative and setting that equal to 0. I just copied in this original function for you. So now when I look at the derivative, I get -12x cubed minus 6x squared plus 30x minus 12. This does make our life a lot easier because now instead of working with a quartic function, we are only working with a cubic function. So I'm going to go ahead and I'm going to use long division. Now again, if I do an f of 1, I get -12 minus 6, which is -18, plus 30, which is 12 minus 12, which is 0. So f of 1 again is a root. Now I can do long division with this, or I could factor out a number. I'm going to go ahead and just do long division with this because I think that's what most of you would probably do. But if you wanted to pull out a GCF, you could pull out a -6. That would certainly make your life a lot easier in the long run. I'm going to suggest that you pause the video right now. I'm going to just show you the final answer for this long division and not walk you through step by step, because I think by now it's probably boring. So after I do all of my long division, I am left with -12x squared minus 18x plus 12. Now, when I go to the next page, we'll be able to talk about how I can rewrite this entire derivative in factored form. So what I have here is my x minus 1 that I did my long division with, and then my solution. At this point, I am going to be taking out my GCF just because it will be easier to factor this quadratic if I do that. So I am going to be pulling out a -6. So -6 times the x minus 1 times 2x squared plus 3x minus 2. And then I can go ahead and I can attempt to factor this quadratic here, which I can do with decomposition, something that multiplies to -4 and adds to 3. So now that I have this factored, I can find my critical points. I've got one critical point when x is equal to +1, another when x is equal to 1/2, and another when x is equal to -2. So what I have done here is I've set up this interval chart with my critical points. I just rewrote the derivative and the original function on the bottom there just because I don't have it anywhere else. I'm sure you do on your page. And I'm going to be able to see where this function is increasing and decreasing. Now, obviously, at these critical points, we already know that my derivative is equal to 0. And so my function will look like this. Now I'm going to go ahead and I'm going to pick some values that make sense. So for this one, I need to pick an x that is less than -2, so I'm just going to pick -3. And if I think about what's happening here, I've got -6 times, that'll be a negative, times another negative, times a negative, which will result in a positive. I need to pick a number between -2 and 1/2. I'm just going to pick 0, so I'm going to get a negative times a negative times a negative times a positive. So 3 negatives and 1 positive will give me a negative. A value between 1/2 and 1, I'll pick 3/4. I'm going to be getting a negative times 3/4 minus 1 is going to be a negative, times 3/4 times 2 minus 1 is going to give me a positive times a positive. That's going to be a positive overall. And a number bigger than 1, I'll pick 2. I've got a negative times a positive times a positive times a positive, which is going to give me a negative. So for the function here, I've got increasing, decreasing, increasing, decreasing. So just to add to what we know about this function, we know it's a degree 4. We know it has a negative leading coefficient, which means that it is starting in quadrant 3 and ending in quadrant 4. The next thing that we're going to be talking about is our points of inflection, and that those happen when our second derivative is equal to 0. So I rewrote our first derivative for you. I'm going to do our second derivative right now, and I'm going to be getting a negative 36x squared minus 12x plus 30. So when I go ahead and set that equal to 0, I'm going to factor out that negative 6, and then I will be able to use the quadratic formula with what I have remaining. So I just did the quadratic formula, super quick for you. My hope is that you're doing these by yourself and just checking with mine. And I get an x of 0.8 and an x of negative 1.1. Now again, I'm going to write this just as a point that we know. So I get an x of 0.8, and when I plug that back in, I get negative 0.33, and the same thing with the negative 1.1. When I plug that back into my original function, I'm getting a 31.26. All right, I've got my chart here with my inflection points. I'm going to be plugging these in. So if I plug in a number less than negative 1.1, I am going to be getting a negative times a positive, which is negative overall. If I plug in a number between negative 1.1 and 0.8, like 0, I'm going to be getting a negative times a negative, which is a positive. And then something bigger than 0.8, let's just say 1, I'm going to be getting a negative times a positive, which is a negative. Now filling that in for the f of x, I've got concave down, point of inflection, concave up, point of inflection, and concave down. So here's a graph of our function just from Desmos, just because I'm trying to save some time and have a nicer graph. I wrote down some of the key points that we had so far. So we had our x-intercepts. Obviously they're happening at 1, at negative 2.9, and at 0.23. Our y-intercept was at 0.2, and then we have some critical points. One of them is at 1, 0, 1/2, negative 6.9, so that would be this local min right here, and then negative 254, so that's our absolute max right up there. And then again, remembering that when we had that root at 1, 0, it was a double root, which is exactly why it is hitting this point 1, 0, and then immediately going right back down, which is helping us get from quad 3 to quad 4. Now, this is a very long question. If I was going to give you a question like this, you would have ample time to do that. So this would not just be your run-of-the-mill textbook questions. I'm just going to give you a quick little intro to rational functions. So just to start, I want you to take a look at these questions and just pause the video for a second and think about the answers. So how do rational functions look? You should already have an idea about what they look like. Can they have maximum and minimum values? Will they have points of inflection? And how do the asymptotes impact the analysis of the graph? So while you're thinking about those questions, I am going to give you your next little part of this video. I do want you to provide a sketch of the 5 rational functions that you're going to see next. They're just basic, easy ones, but it is always easiest to graph this if you are putting it in factored form first. That way you could see where your asymptotes are, and just make sure that you're double checking your sketch with Desmos or some other graphing calculator. So there are the 5 questions. You will probably have to pause the video to write them down.